Hello all. Our today's topic is op-amp as a summing amplifier, or it is also called as op-amp as an adder. The summing amplifier is one of the circuits and configurations of the circuit is based upon the standard inverting op-amp. The name of the circuit suggests the summing amplifier that is used to combine the voltage existing on many inputs into a single output voltage. The inverting op amp has a single input voltage applied to its input terminal. If we connect more resistors to input terminal, each input value is equal to the input of the resistor. Input of the resistor will be end up with another op amp circuit named as summing amplifier. You can see the circuit diagram for the summing amplifier as. The term summing amplifier is also named as an adder, which is used to add two signal voltages. The circuit is simple to construct and it enables to add many signals together. This kind of amplifiers is used in a wide range of electronic circuits. For example, an audio mixer is used to add the waveforms together from various channels before sending the mixed signal to a recorder. You can see another adder with three input voltages as VA, VB, VC as shown in this circuit diagram. We saw previously in the inverting op amp that the inverting amplifier has a single input voltage Vin applied to the inverting input terminal. If we add more input resistors to the input, each equal in value to the original input resistor, that is Rin, then we end up with another op amp circuit called as summing amplifier or voltage adder circuit as shown here. Let's see this circuit diagram and you can draw this diagram for your reference too. In this simple summing circuit, the op amp voltage V out now becomes proportional to the sum of the input voltages V1, V2, V3, etc. You can see the input voltages as V1, V2, V3, the input currents as I1, I2, I3, and input resistors as R in. And the virtual earth or summing point is shown in this diagram. The RF, that is feedback resistor, is shown and IF feedback current is also shown here. The positive or non-inverting terminal of this circuit is directly connected to the ground, that is to 0 volt. Again, we can modify the original equation for the inverting amplifier to take account of these new inputs. Thus, we got IF is equal to I1, I2, I3 and it is equal to, from Ohm's law, minus of V1 upon Rin plus V2 upon Rin plus V3 upon Rin. You can refer the diagram here also. And we know the inverting equation as V out is equal to minus RF upon Rin into Vin. Gain for inverting operational amplifier is what? V out upon Vin is equal to minus RF upon Rin. And so for V out, it is minus RF upon Rin into V in. Equation for voltage for inverting amplifier. Then minus V out is equal to RF upon Rin into V1 plus RF upon Rin into V2 plus RF upon Rin into V3. This is the output voltage formula. Here, if all input impedances or resistances are equal in value, then we can simplify the above equation to give an output voltage of a summing amplifier equation as V out is equal to RF upon Rin V out or minus V out is equal to Rf upon Rin into V1 plus V2 plus V3 plus etc. From the previous equation, what V out or minus V out is equal to Rf upon Rin is taken common and remaining V1, V2, V3 are taken into another bracket in the summation form. We know or we have an output now like minus V out is equal to Rf upon Rin into V1 plus V2 plus V3 plus dash dash or etc. Number of input voltages can be added. Now we have an op-amp circuit that will amplify each individual input voltage and produce an output voltage signal that is proportional to the algebraic sum of the three individual input voltages as V1, V2 and V3. We can also add more inputs if required. Here the input signals are effectively isolated from each other by the virtual ground node at inverting input terminal, as you can see in the circuit diagram. Note that when the summing point is connected to the inverting input of the op-amp, then the circuit will produce the negative sum of any number of input voltages. Likewise, when the summing point is connected to non-inverting input op-amp, it will produce the positive sum of the input voltages. Again, if individual input resistors are not equal, then the equation would have to be equal to minus V out equal to V1 into bracket Rf upon R1 plus V2 into bracket Rf upon R2 plus V3 into bracket Rf upon R3 etc. Means here input resistors R1, R2, R3 are taken separately in place of Rin. If they are equal, we can take as Rin, and if they are not equal, then we have to separate them as R1, R2 and R3, and so the equation. To make maths a little easier, we can rearrange the above equation as minus V out is equal to Rf. Rf is common. Rf into V1 upon R1 plus V2 upon R2 plus V3 upon R3 etc. This allows output voltage to be easily calculated if more input resistors are connected to the amplifier's inverting input terminal. The input impedance of each individual channel is the value of their respective input resistors, that is R1, R2, R3, etc. Sometimes we need a summing amplifier or summing circuit to just add together two or more voltage signals without any amplification. By putting all of the resistances of above circuit to the equal value, then op-amp will have a voltage gain of unity and output voltage equal to the sum of all input voltages as shown. Okay, see the diagram. Thus, the summing amplifier is a very flexible circuit indeed, enabling us to effectively add or sum together several individual input signals. If the input resistors R1, R2, R3, etc. are all equal, then a unity gain inverting adder will be made. However, if input resistors are of different values, then a scaling summing amplifier is produced, which will output a weighted sum of input signals. Now let's see the practical example for a summing amplifier. You can refer the previous diagram for this. For two input resistors are connected to inverting terminal of op-amp. In that circuit, if Rf is equal to 10 kilo ohm, R1 equal to 1 kilo ohm, R2 equal to 2 kilo ohm, and V1 2 millivolt, V2 5 millivolt. Okay, Rf mean feedback resistance. R1 and R2 are input resistance and V1 and V2 are input voltages provided to the circuit. Then using the previous found formula for gain of the circuit, we can have the gain formula as V out upon V in, and as that is the inverting operational amplifier, we have seen the derivation or expression for that V out upon V in is equal to minus Rf upon Rin. We can now substitute the values of resistors as R1 and R2. Therefore, gain A1 is equal to 10 kilo ohm divided by 1 kilo ohm minus Rf upon R1. So, minus 10 is the answer for input resistor 1 R1 equal to 1 kilo ohm. And for input resistor R2, A2 or gain will be minus 10 kilo ohm divided by 2 kilo ohm. So, the gain is minus 5. Again, V out is calculated as A1 into V1 plus A2 into V2. V1 and V2 are input voltages. So, output voltage is equal to gain into input voltage, as the gain equal to out upon in. Therefore, V out is equal to minus 10 into 2 millivolt and plus minus 5 into 5 millivolt, and you can calculate, and you will get the answer as minus 45 millivolt. Therefore, the output voltage of summing amplifier circuit is given as minus 45 millivolt and is negative as it's an inverting amplifier. I hope you have been understood op-amp as an adder using inverting operational amplifier configuration. If there is any doubt regarding, feel free to ask me. Thank you.